welcome to the Ideal Spaces podcast, the podcast that celebrates the ideal spaces of the past, present, and future. I'm Flora and Ulrich, creative director and host of this series. I'm joined by my colleague and director of Ideal Spaces, Ulrich Gehmann.
Yes, hello everybody, great to be here. I'm looking forward to continuing our discussion on different types of space. So far we've spoken about formatted spaces and managed spaces, and in these contexts and related to the idea of the function, the aspect of today's theme of our podcast will be for sure very interesting.
And it wasn't that long ago, Ulrich, that we were putting together our paper on abstraction and the Gothic cathedral for a conference in Canterbury. And one of our main interests there was this recurring pattern throughout history of people always having been dependent on and trusted these invisible forces and abstract spaces to better understand the world around them and themselves. Whether that's a faith in God or a faith in the internet, algorithms, or cyberspaces. Listeners may be wondering where exactly I'm going with this, and if you are, I'm pretty confident that this episode will shed some light on some of those buzzwords. Our guest today, Ed Finn, is an expert in this field. His research focuses on the workings of imagination, digital culture, creative collaboration, and the crossover of humanities, arts, and sciences. He's also the author of the 2017 book, What Algorithms Want: Imagination in the Age of Computing, among many other brilliant books. Ed's also the founding director of the Center for Science and the Imagination at Arizona State University. It's an incredibly interesting department that gets people really thinking about the kind of future that they want to live in. They organise fascinating projects that bring together artists, authors, and educators with scientists, technologists, policy thinkers, and community members. It's the kind of collaborative way of working, actually, that Ideal Spaces Working Group is all about. So first things first then, welcome to the podcast.
Thank you so much for having me. It's a pleasure to be here.
Great to have you here. We're looking forward to exploring some of those topics in more depth, and also getting your perspective on the digital world, patterns in human behaviour, and much more. First thing I was thinking about, really, I tentatively mentioned algorithms in my introduction, and I can't say that I'm an expert myself, but of course it's the focus of your book, What Algorithms Want. And I think algorithms are one of those things that people hear of, they read about, generally kind of understand, but not necessarily in much depth. So for the benefit of our listeners, before we kind of dive into that world of algorithms, could you tell us what exactly algorithms are and also what they're used for today?
Absolutely. And it turns out to be a surprisingly complicated question. And this is part of why I got interested in the topic in the first place, because people throw this word around all the time. You hear people talking about algorithms for stock trading, or the way that your phone works, or how spell check works, or in mathematics and computer science and things like organizing and sorting data. But the deep history of the idea of the algorithm goes back much farther than the era of computation. And it encodes a lot of everything that you've just talked about, this idea of our belief in abstract systems, because it's an idea that's so simple and yet so complicated at the same time. An algorithm, very simply, is just a recipe. It's a set of steps that you can follow that should predictably lead to the same result. So in that way, it's very much like baking a cake. So theoretically, once you write down the steps, then anybody should be able to make the same cake. But if you've ever tried to bake a cake from a recipe, or done the same recipe more than once, you know that it's actually a lot more complicated than that, and that there's all sorts of other knowledge and information that is often hidden out of sight for the clarity and simplicity of the recipe. So if you ask an engineer or a computer scientist what an algorithm is, they might say something like, it's a method for solving a problem. So you have a bunch of files and you want to sort them efficiently. there are various algorithmic solutions to doing that. And so there's a very pragmatic engineering approach that is often what people in technical fields mean when they talk about algorithms. And that is underpinned by a worldview, an engineering worldview, which you can caricature as the world is divided into problems and solutions. And if you can't define something as either a problem or a solution, it's not very important, right? And that a huge amount of effort in engineering spaces, and certainly something we see in computer science and its application to cultural life, is defining problems. And you can't actually bring computation to bear until you have a well-defined problem. Though maybe we'll talk more about that. That's an increasingly complicated thing, complex statement I just made, as we're applying computation to all of these murkier and more ambiguous areas of our social and cultural lives. So the other interesting root of this definition of algorithm stems from the way that the modern field of computation emerged. So in the 1930s, 1940s, 1950s, philosophers, mathematicians, logicians, people like Bertrand Russell and Alan Turing, Alonzo Church, were very interested in the boundaries of mathematical logic. And can you prove that something is computable or not? That if you have a mathematical question, that there is actually an answer to it, that you will be able to arrive at in a finite amount of time. Because some mathematical problems, like say calculating pi, are infinite and open, and you can never arrive at a complete solution, or you can keep calculating it forever. But other things should have what is called an effectively computable answer. And Alan Turing, I believe, described this as something that a person sitting down with a paper and pencil would be able to calculate in a finite amount of time. And so Turing invented the thought experiment of the Turing machine, which has famously shaped how many people think about computation today. And he created a mathematical proof for this space of mathematics that was effectively computable. So he was able to define, and intellectual dialogue with some of these other people as well, who were also coming up with these proofs. He was able to prove that a subsection of mathematics was effectively computable. And what's interesting about that foundation over time is that first of all, everybody was kind of sad and depressed because it was such a small area of mathematics that was effectively computable. There are so many problems where we still didn't know that we didn't have this kind of guarantee of a certain form of rationality and agency, because this really matters. It's not just an abstract question; it's a practical question. You need to know whether certain problems are going to be answerable if our infrastructure and people's lives depend on it. And so it was initially dismaying, I think, to many people that this was such a small space. But if you think about the framing of effective computability and what problems we can use computers to address, that space has been expanding and expanding ever since the 1940s and 1950s. And we've moved from very limited applications to all of the ways that now we are relying on computers to do things like evaluate loan applications and suggest potential romantic partners and trade stocks on the stock market, suggest sentencing guidelines for people who have been convicted of crimes. These are really important jobs that we're now outsourcing to these machines and that we have decided are effectively computable. So I know this is a very long answer. I warned you.
No, it's okay.
But one of the trends that I point to in my book is that there's this desire embedded in the idea of effective computability. And we're making that space bigger and bigger because we're trying to make more of our world effectively computable.
This is the interesting point, and this leads to my first question. If you look at the basic worldview behind it, what is this technical worldview you addressed? What is the very essence of algorithmic abstraction, not in mathematical terms, but seen on the base of this worldview? And what about this worldview as an Occidental cultural trait specific for what we call, in summary, the Latin West or the Western cultural sphere. And for me, it was very interesting that for the first explicit times after Plato and the Pythagoreans already, it appeared as architecture, as organizational architecture in the Gothic cathedral. I want to refer to what you quoted on page 133 of your book, where you said the space of algorithmic abstraction has entirely subsumed reality. As this is an endpoint of a development, so to say. But what before it in terms of this worldview?
So this is a really rich vein, and I frame it in terms of the Enlightenment and that Western European ideology and epistemology of knowledge. To say that we are going to count everything, we are going to number the universe for the purpose of mastering that universe. Now, I will say that when you look at this more deeply, it's older than the existence of the West. It's older than that cultural frame. The word algorithm comes from the Middle Eastern mathematician and philosopher Muhammad ibn al-Khwarizmi, whose work also gives us the word for algebra. And it's worth remembering that the fundamental principles of mathematics are much more global and nuanced. This isn't only a project of the West, but it's something that has become very closely identified with not just the Enlightenment, but also the colonial and imperial projects of the Occidental West. But just as we talk about the Gothic cathedral, that's a pre-Enlightenment tradition, and I think reflects a different kind of relationship with knowledge and time. But again, what it has in common with the Enlightenment, and I use the encyclopedia as the sort of emblematic tool of the Enlightenment in the book, what the cathedral and the encyclopedia have in common is that they are structures that exist outside of individual biological agency and attempt to create agency and intent across time in a collective way. And they require different kinds of rational engagement, but also a kind of faith and belief in this superhuman process.
Mm. The encyclopedia as well, it's like a dictionary. It gives us the tools that we need to go about our daily lives, almost like the algorithms.
Yeah, and what I think is really compelling about the encyclopedia, and I tell very briefly the history of the Encyclopédie Française, the first, what is by many considered the first modern encyclopedia that emerged, it sort of in conjunction with in the decades before the French Revolution. And some people have colorfully argued that this was the book that caused the French Revolution. That is also a kind of algorithmic structure, because the whole point of the encyclopedia is not that it is perfect and not that it is merely a repository for knowledge, but that it encodes this early version of the scientific method, this idea that we know that it's imperfect, but it's going to be this collective effort of thousands of people, and we're going to gradually improve it over time, and we're going to cross-reference. We're going to create this hierarchical structure of knowledge, once again, counting and numbering and mastering the universe. And that structure of knowledge was blasphemous, revolutionary, because it put theology and the study of God as just a subunit, just one component within this broader structure of knowledge. So it implicitly said knowledge, right? Knowledge is the supernumerator. Knowledge is more important than God. That's why people think that it was a contributing factor to the French Revolution. And really the modern era of the Enlightenment and the triumph of humanism, rationalism, and this vision of the pursuit of knowledge as the sort of the fundamental mission of the Enlightenment.
And it's interesting again that an encyclopedia or dictionary is something you can pick up and read. It's very visible, although it's referencing a lot of systems that are invisible. How did it develop from this visible system then into this invisible system of algorithms that you use on a daily basis? The moment I turn on my computer and I'm typing away on Google or on Instagram on my phone. It's, something I'm not really aware of, but it's so important. And without those things, we would just lose our way almost.
So this is where I think we have this transition from reason to faith. And to really use the encyclopedia, you have this rational relationship to it. But at a certain point, you're also believing in we might call the ideology of the Enlightenment, right? And you're buying into this vision, this larger mission to one extent or another, or you're at least collaborating in it, participating in it, even just by reading the encyclopedia. And I think what has happened as our tools and our cultural structures around this kind of Enlightenment civilization, if you want to call it that, as that has gotten more sophisticated, we've elided away more and more of the details so that you no longer need to understand how all of the tools work. You're just doing it entirely on faith. And that's what we have now. If you think about a modern iPhone, there's probably no single human in the world who could build that iPhone, who can comprehend in a single human mind all of the technical details and proficiencies to actually construct that device. It is also a kind of superhuman device. And that is how everything works, right? Everything is interdependent and everything requires these modular, highly sophisticated, discrete chunks of knowledge that have been so simplified for outside use that only a very few people really understand how they work, and everybody else is just plugging them in and taking it on faith.
That is a very interesting point. Also, this leads to another area of investigation and to another question, namely how systems, how these algorithmic systems are creating and influencing realities in the world, which happens today, of course, but there has been an evolution, as you already indicated it. And what can we say in general principle terms, how these systems, these algorithmic systems, are able to generate realities?
So at this point, I think it's worth bringing in another thread that I talk about in the book, which is the way in which we are shaped by our tools. And you can trace that history back to language itself. If you think about language as the original technology, though a huge amount of our collective effort is instilled in teaching our children language, teaching them how to read and write, and reproducing this sort of, you can think about it like, I really resist analogizing the human brain to a computer. So maybe I won't
understand.
Yeah, right. But, this is a way of establishing the cultural programming, right? For our so building from that, language plays a huge role, not just in communication and identity, but really in perception. If you don't have the word to describe something, it's much harder to see that thing. And there's interesting work in linguistics in things like color theory, and different cultures may not have different words for particular colors. And it's not that those people have eyes that cannot perceive those colors. It's just that they're not named, they're not noted, right? For practical purposes, they don't exist. So if you think about the things that we name now and all of the ways in which we are now relying on computation to do our thinking and our seeing for us, it really does impact what is real. So we outsource so many of our memories. Most of us don't remember any phone numbers anymore. Many of us probably don't remember any birthdays anymore because we rely on computers to tell us when these things happen and how to be in touch with one another. From those very simple examples, you can build up to more complex things like the ways in which we conduct scientific research. So much of our research is not based on direct observation. It's based on computational models of reality. And obviously, we've had these tremendous advances in scientific research, and computation has been a really important part of that in a field like astronomy, for example. But it also comes with its pitfalls. There was a moment several years ago when people realized that there was a basically a bug in one of the popular fMRI software packages that people were using to study brain activity. And so there were thousands of research studies that had incorrectly relied on results from the software package because most of the people using the software were not computer scientists, right, or statisticians. They were neurologists or whatever. So this is just a small example of the ways in which we depend on these systems for really sort of a phenomenology of the world as it exists today, for just our experience of reality. And you can, I think anytime you look at your phone to find out what the weather is, rather than go outside or look out of the window, you have proven that point.
That is a very interesting point. When the model becomes the relevant reality we are referring to.
Well, exactly. What happens when technology becomes our reality, in that it poses a real threat and actually could outrun us? I think it was about maybe a year ago or so in the UK where we had a prime minister blaming mutant algorithms for A-level students receiving lower grades than their predicted grades. And it's kind of cropped up, I think, time and time again, this word mutant, which I think is really interesting, this idea that technology can kind of get out of hand in some way. And then the mutant algorithms are kind of these outside forces that act upon us rather than being these kind of tools, I guess, that help us understand the world, make decisions. What would you say about that relationship?
Well, one of the other books that came out in 2017 was a new edition of Mary Shelley's novel Frankenstein that I co-edited with a couple of people.
Yeah.
And this is another long-standing thread. It's a consequence of this very old relationship we've had with our tools, where we shape our tools and then they shape us. But we're also trying to use our tools to master the universe in different ways. And that is very much what the Frankenstein story is. And so we're deeply conflicted about when these systems are on the inside and when they're on the outside. And what I think we are just beginning to grapple with is this idea of computational systems, algorithms that are thinking with us, that we are thinking through these tools. And we really don't even have a good vocabulary to describe this. And it's been this sea change over the past couple of decades that is so profound that it is almost invisible. So if you think about what it means to be a writer or an editor or a journalist today, as opposed to a couple of decades ago, and the thousands of times per day that person is now relying on algorithmic filters and search engines and recommendations and influences that shape not just the foreground, the thing you're actually trying to research or find out about, but also the periphery of everything you're even aware of. Every book, every piece of music that you hear of, every piece of news that you get has been touched by computation in some way. And so we don't know how to think about that as a change in ourselves, but it is a change in ourselves. We are collectively shaping these systems by our own actions. They are observing us even as we're observing them. So we're in this feedback loop. So we don't know how to think about them as inside and outside at the same time. And we also don't know how to think about them as systems that have agency in our world, because their agency is so alien from human agency. You can blame the algorithm for the A-level grades, but the algorithm doesn't care, right? There's no, so what, right? How do you deal with the agency of this algorithm, which of course ultimately is really the product of a bunch of flawed human decisions, because we are making all of these things and we are making them imperfectly because we ourselves are imperfect. So we're just beginning to contend with how to wrestle with these systems that transgress the boundary between inside and outside all the time.
That's a very interesting aspect also. No? It refers to the capacity of an algorithmic brain. Let's use it as a metaphor, at least the algorithmic brain, to adopt quasi-human qualities. And this cannot be the case because an algorithm is an algorithm, and that's it. No? Or what do you think about this transgressing and this inside-outside is a very interesting aspect.
So I think that we're still searching for the right metaphors What we've done
Mhm.
over the past couple of decades is move from an infrastructure layer of computation where we might have, RoboCop or R2D2, but mostly these were sort of fantasies of computational systems interacting as persons. They were just part of the background. But now
Mhm.
increasingly we are creating these systems that are taking on human personas and human forms. You have Alexa and Siri, you have chatbots, and that carries a lot of freight with it, a lot of cultural context. And we can get into all of the ways that is fraught. But I think that what we should be doing is coming up with different metaphors instead of trying to pretend that these systems are human when they're really not. We could think about other metaphors that capture some of their alienness. And one potential direction for that is to think about ecological and biological metaphors. Because if you think about a wild animal or a tree or an entire forest, we know that these things have a kind of agency and they operate in the world, but we also know that they're not human. And we can communicate with a dog or a fox in certain ways, but we also know that intelligence is not, it's a non-human intelligence, but we have a kind of much older evolutionary frame of reference for understanding and engaging with those alien species. And we cohabit with lots of alien species when you think of it in that way. I was talking with somebody else recently about this robot dog named Spot. Boston Dynamics has a robot called Spot, and they're really leaning into the dog metaphor. But of course, just like Spot is not a human, Spot is also not a dog, right? And so these biological metaphors also have to be treated with care so that you're not creating a false set of relationships and a false set of impressions. But I think that might be better because when you think about something like Amazon's Alexa, Alexa is not a person. Alexa isn't really even a tool there to help you. Alexa is this giant surveillance system to capture millions and millions of people's speech patterns and build up this database of natural language processing. And it's a system to sell you stuff. It's this sort of consumer endpoint. And so the relationship that we have with the system is one, we don't have good language, good metaphors, or cultural frames to contend with these new relationships.
Yeah, that's a very interesting point because, in my eyes at least, finding the right, proper metaphor is essential for understanding the phenomenon. Also, when you, for instance, use the metaphor to compare these kind of systems with biological systems. A biological system may contain humans, but in itself it is not human, as you had it. But how to understand an entire system in terms of biology? I cannot personalize an ecosystem, for instance. I cannot build a real relation to an ecosystem. For instance, when I'm stepping into the ecosystem of a jungle, I can be fascinated. And so on. But I have no direct relation. Also with a fox, I can have a relation due to evolutionary heritage, as you addressed it. But with these new systems, I cannot have a relation. This is one aspect. And the other aspect, as you addressed it in the case of Alexa, as an example, as a case example, we have a clear socio-economic context, which is also the relevant cultural context in play. And this is our recent capitalistic system. All these systems have one end, as systems like Alexa, to serve these capitalist systemics. And these are two different aspects. Also the metaphors and the concrete systemic contexts these systems are embedded in.
So you make a great point, and I would say, yes, that's exactly why we should be using these metaphors because we can't have relationships with these systems in the way that the name Alexa would suggest. Alexa is not my friend. Alexa is not a person who lives in my house. And in some ways, I think it's much more apt to think of Alexa as a jungle or a forest. And the reason that I think these metaphors are valuable is to show the vastness of so many of these systems. Because one of the most deceptive parts of the system is that, as in the movie Her by Spike Jonze, we might interact with a particular device, a particular voice, a particular name, and have this impression of personhood. But in fact, there's this vast collective that is the tip of the iceberg, and there's this huge superstructure somewhere else that we're not interacting with, and that's not directly interacting with us. And I also use the metaphor of swimming in the ocean. When you go swimming in the ocean, you don't have a relationship with the whole ocean. You cannot know the ocean. And you just have to accept that fact. But you can still have, depending on how we want to frame the word relationship, you can have a relationship with the ocean. You can have strong feelings about the ocean. You can have, and if you have a forest, if you're near the Schwarzwald and you walk through it every day, you can have very complex relationships and you can gradually observe different parts of that system. So representing some of these systems as complex systems and starting to understand their underpinnings is very important, just as a truth in advertising sort of move, but also allows us to get into the second question you're asking, which is about capitalism, because that's the other major form of deception involved in so much of our relationship with computation today, which is that it is really all about capitalism and funneling huge amounts of attention and energy for the benefit of a tiny few, of a small number of people. And that most often we're not even the consumers in the system. We are just the product. It is our attention and our personal information that's being marketed elsewhere. So we're have very little agency in many of these systems. And if we could see the bigger picture, right, see behind the screen, we would start to see some of those relationships. So many of our capitalist computation systems right now are about, push this button and a car will magically appear at your door. Push this button and a product will arrive at your house overnight or in a few hours. And I talk about these are forms of abstraction. It takes away all of the messiness and complication of life for the person who pushes that button. But it turns out that messiness, that complication doesn't disappear. It just gets shunted somewhere else, right? And so now we have people in these really dystopian conditions working in giant factories and warehouses trying to fulfill all of these orders. We have drivers who are living these really untenable part-time work lives, trying to make ends meet in the gig economy. So I think that finding better metaphors is also a way for us to contend with the relationship between computation and capitalism.
It's interesting, isn't it, this idea of contending with something. Mm-hmm. Part of me thinks people shouldn't really need to understand the complex algorithms that we actually meet on a daily basis, but probably don't even know about. But then again, actually, there probably should be some kind of awareness of how these systems work, because off the back of an order you might make to Amazon, let's say, that arrives within a day, there are consequences elsewhere in society that people aren't really engaging with. And I also find it interesting that in the UK, at least, primary school children are now doing coding courses, and that was never on offer to me when I was that age. And as a result of that, coding is really alien. But I guess, actually, it's great that computational systems are becoming more relevant to younger audiences as time goes by.
Your whole life would have been different, Flora, if only you had been taught to program in kindergarten.
Well, that's true. You never know.
I actually support some forms of fundamental computational literacy, algorithmic literacy. I think people need to understand how these systems work so that they can understand their weaknesses and their strengths as well, their drawbacks, and start to understand, I talk about this in the book as the gap between computational models of reality and the real world. And as you were saying, when things go wrong, humans end up having to bridge the gap and negotiate it and fix things. We bend over backwards to make the computational model seem more efficient and correct and helpful than it really is. We repeat ourselves for the microphone and are more patient with the machine than we would be with our own children, right? So when we're talking about this question of literacy, I think it's important to, it's not that everybody should learn how to code, but everybody should have a basic understanding of the sort of structures of symbolic logic and this gap, this relationship between the kinds of things that computers are good at and the kinds of things that humans are good at.
And a general awareness as well, how your data's being used. Because I think a lot of people don't really realize, when you have to accept cookies and things like that, people just kind of click, oh, yeah, accept this, accept that. And they don't really understand as well how the system's working and where their information might end up.
Yeah, I think we all are making a lot of really bad deals when we're entering into these contracts where we don't understand what the nature of the deal is. Many of them are presented as this is a free service. This is just a thing you can come and use. But it's always a transaction. And so there's always a price to be paid. And sometimes it's a price well worth paying. Many of these services are really important and valuable for us in our lives. But most people using them are probably not really aware of the consequences of their interactions.
That's the point again, as regards also, for me at least, is a capitalist real life context. If we use this metaphor of the jungle, as entering the jungle as a consumer, and this I am in final terms, in this existing capitalist context. If I do not understand the jungle, it does not matter if I like the jungle or not. It does not matter what is my personal relationship to the jungle. And I will get part of the jungle while entering it. I am not the outside observer, as in times of an 18th century encyclopedia. I'm in the midst of things.
That's right. There is no outside to the computational world we have created. The other myth we still cling to is this notion of the objectivity, the perfection of the computational space, because it has this, foundation in mathematics to say, like, oh, well, this is the space of perfect logic and rationality. And that suggests that exists outside of reality, where reality is always complex, it's contingent, it's messy, it's ambiguous. And the computational model should be better, more perfect, because everything is a 1 or a 0. But that's not true, and it's just a copy, an impersonation of the real that is never going to be as nuanced as reality.
Yeah. And so to wrap up our discussion, we like to ask all our podcast guests for their perspective on the future. I was going to ask you about, whether the benefits of algorithms outweigh the losses or negatives, but I feel like that is too broad a question for too kind of complex an issue. So where do you think we'll go from here? I mean, what does the future hold? And what would you say the ideal space would be if we take space in the broadest sense, being the kind of visible spaces around us and also the kind of invisible networks and digital spaces, or both, given that they're so closely connected?
So the first thing to say is that there's no unringing this bell. There's no putting computation back in the box. Mm-hmm. This is the world that we live in, and we are cohabiting with all of these computational systems that have agency, certain forms of intelligence, not in the singularity sense of super intelligence, that's going to take over the world, but in the sense of the same sense that corporations have a superhuman intelligence and agency. And many of these systems, they're not just algorithms, they're computational structures, they're culture machines. They're made up of people and code and laws and regulations and all sorts of other stuff. And so we have to strive to make these relationships and these structures more equitable, more just, more inclusive. Yeah. I think that perhaps the greatest challenge that our species faces right now is that too few people feel empowered to think about the future and to make the future. And we need to be much more inclusive about who is involved in that project. And when it comes to computation, we need to build these collaborative and cooperative relationships, which means new metaphors. It means more openness and transparency, and a relationship that's different from the cathedral. Getting back to the Gothic cathedral from the beginning, there's this quote from a computer scientist that I had in the book. Software is like a cathedral. First you build it, then you pray, which really, adopts this sort of faith-based model and says these systems are so complex that we don't have that much agency over them once they're built. And we need to get better at balancing and sharing agency with our machines. A metaphor I've used sometimes is this idea of a tennis partner. We need to find that, and that requires a certain level of trust. We need to be able to trust these systems in certain ways and have them trust us also, right? So there's this shared, that is essential to teamwork, to collaboration. And those are the relationships we need to create. When you think about automation and new forms of work, it's really important that we create spaces for meaningful human engagement and human work. So this isn't about replacement or about people being in conflict with computational systems. If we just treat humans like bad computers, which is what so many of these systems seem to do right now, is just to treat them like untrustworthy bad computers, that's a problem. And if we try to treat the machines like humans, that's also not going to work, right? So we have to find this differentiated collaborative structure where different entities can have different roles, but there's enough trust and agency and transparency that everybody can work together. And I think that's the ideal space. That's what we need to work towards, to have a more positive and successful 21st century as we continue to we've created this new ecosystem of artificial life in the algorithm, and we have to contend with it now. We have to take responsibility.
Mm-hmm. No, I think that's, actually very refreshing to hear, because I think the big wide world is a pretty scary place at the moment. But there's still evidently so much we can all do to confront those challenges like climate change, economic inequality and injustice. And it's just about getting that balance of being empowered, finding that openness and collaborative approach that you talked about. So I think that's a really good place to end our discussion. So thank you so much, Ed, for joining us.
Ed, I also want to thank you for these aspects you lined out.
Thank you so much.
And thank you everyone for listening. If you've enjoyed this episode, you can subscribe to the Ideal Spaces podcast on iTunes, Apple Podcasts, Google Podcasts, Spotify, anywhere you find it. You can also find us on Twitter at Ideal Spaces or on Facebook at Ideal Spaces Working Group. Thanks again and see you next time.